Hi, good morning, Amsterdam. It is great to be here at the Open Compute Summit. I actually spent last week here at the Open Networking Summit, which was a summit focused on a lot of the software open source projects that I work with. So it's great that we were able to have that continuity and be able to talk to both audiences about the collaboration that we've been doing. So. What I'm going to talk to you about this morning, and we're going to end up seeing a demo around, is around the virtual central office. And it's a term I've been hearing, sort of used more and more here. But for those of you who, don't have a long background in the telecom industry, central offices are places where, phone gear and a lot of gear necessary for kind of general internet connectivity has, occurred for a long time. These days, or sort of in the past, it's been mostly, very proprietary gear, very geared towards one function, whether it's a router or a switch or a CG NAT or something else. And as the telecoms are modernizing their infrastructure more generally through the use of SDN and NFV, so moving a lot of the intelligence into software and using less purpose-built equipment and more white box equipment and things like OCP solutions, which we're very excited to see. They've been on this journey to modernize the central office. That allows them to start offering a lot more services, to have a lot more flexibility, a lot more service agility, and really just sort of a lot more software-oriented modernization. So, where we are where we have been are sort of that plethora of networking gear out there. And where we've started to get to today is really beginning to start putting in, sort of moving away from that bespoke hardware, moving to things like OCP solutions in the CO, beginning to use open source software to provide a basic platform for a lot more applications out there. We've started disaggregating in a lot of places, so stuff is a lot less monolithic. And sort of where we are is kind of in the journey around the middle box. And then looking ahead, we'd like to see a lot more open source hardware out there. We'd like to continue to look at things like cloud native and deploying, sort of moving from VMs to even containerized applications out on the CO, and then going from the CO even further and further into the edge. I was just hearing Bill talk about sort of some edge groups going on, looking at edge optimized hardware. We have a lot of work going on in Linux Foundation projects looking at sort of what the software requirements are. So I think it's great that we continue this collaboration together. So there are a lot of use cases that can be addressed by the reimagining the central office. Last summer, we collaborated with OCP and a number of organizations on a first version of a virtual central office, and there we shared residential use cases. So we onboarded what's called a BNG in telecom world. If you've ever spent any time with telecom people, you will know that we cannot resist an acronym. So BNG basically sort of provides subscriber-oriented services for residential. So we showed that we could get that onto OpenStack software using Open Daylight as an open source SDN controller and onto some OCP servers. We also showed some enterprise virtual customer premises equipment. Use cases. So when we thought about doing this year, we wanted to show mobile, and 5G is a important thing these days. When you talk about the VCO, Virtual Central Office, for residential and enterprise, you get a lot more flexibility, a lot more agility. We did some business modeling with Intel and saw that you could get around 30% CapEx, OpEx reduction. The difference between that and sort of looking ahead to the 5G mobile network is really a lot of the 5G use cases really demand this. So it's a baseline necessity to be able to go into the central office and even further onto customer sites, cell towers, cell sites. And so it's an area of a lot of focus across a lot of projects going on these days. And that's sort of where we're going to spend some time today. So, kind of over the past several years of our NFV and SDN journey, open source hardware journey, we've gotten a lot of experience, sort of in our central data centers, in our central clouds, beginning to move that way. So, now we're going to that network edge where, you've got central offices, towers, where you've got your LTE connectivity looking ahead to 5G connectivity. Then going out to the customer premises. And then, what that enables is a lot more high bandwidth, low latency applications. The requirements from 3GPP for 5G are very stringent that way, so that you can get really cool AR, VR things, autonomous vehicle connectivity, drones. So if I were Oprah, I would say look under your seats. You've got some AR, VR goggles, and that's the demo that we're going to show. Don't have that level of resources. So what we're going to be showing shortly is going to be more of a phone call. We're going to talk a little bit more in detail, but sort of what I want you to kind of take away from this is open source software, open source hardware. We've done a lot of work to sort of the underlying platform is going to be a 5G-enabled mobile core, as well as virtualized radio access. So these are a lot of the steps necessary for us to deploy 5G out there, and so I'm really excited that we'll be able to show some of that today. So I've talked about some of the requirements sort of, as I've been talking, but really the massive scale, if you think about all these edge sites, being able to manage those, being able to virtualize things like the RAN, being able to put your different types of network splits into software so they can occur at different places based on the sort of use case that you're trying to do, building things on top of sort of well-known components out there like OpenStack and Kubernetes, being able to do service assurance and end-to-end orchestration. So sort of taking those telecom requirements, we've put together a demo. This is our general software stack. You can see that we've got the OCP for servers, hardware, white box switches, and then we build on top of, for this, OpenStack, SDN, a controller for Open Daylight to program the switches, also do some of the SDN control work. And then we have got a number of element management and applications on top of that. Just point out Open Air Interface is a new open source project we work with. They're providing a lot of the virtualized radio access components and the sort of the next gen mobile core. So with that being the software stack, I would like to invite on stage Rajeev Sharma to talk about the hardware aspect of this entire demo that we've built. Rajeev, please come join me.
Thanks, Heather. Hi, folks. Thank you. So Linux Foundation is working on the software stack for the past 2 years, and today I'm going to talk about the hardware. As you guys see on the slide, on July 20th, Mitek, they boxed up all the equipment that was necessary for the VCO demo. And a few weeks later, they pretty much put all that equipment onto the truck. And a month after the initial conversation started with Mitek, we had that hardware installed onto the Amsterdam data center. After that, 10 days after the hardware was here, Red Hat team remotely installed the software and made sure that everything is all OK. And 30 days later, right now here we have, everything is all set up for the VCO demo. The key takeaway from this slide is if we go back 30 days earlier, when the Red Hat team was trying to install the software, debug, and triage it, by the way, we had the hardware right there a week ago for the ONS Summit. So literally, we didn't even need 4 weeks. We only needed 3 weeks. Back to Heather.
So just really quickly, this is the topology of the lab back in San Jose. So what we're emulating here is a central office in San Jose and a branch up here on stage. So back in the Cumulus lab, we have a number of compute and storage nodes, a full leaf and spine switch fabric, and some handsets in a Faraday cage connected to software-defined antenna. Attila's going to talk a little bit more about those when I bring him up for the demo. But the thing is, this is what's back in San Jose, and it's connecting to this branch here with the hardware from Circle B and MyTech. And so just want to make sure that we understood how everything was connected, and you can sort of keep talking about what we've got here on stage.
All right, so we took a very simplistic approach to virtualize our central office. So let's take a quick snapshot of the hardware that we have it right there for the VCU demonstration. As you guys see on the slide here, we have 4 Open Rack compute sleds using a shared power, and it is connected to the open source switch. And I'm going to talk more about these Open Rack compute sleds in my next slide. As you guys see here, these sleds have been housed in an enclosure, right? And I will also talk about the enclosure in my following slides. So first of all, thanks to MyTech for providing us the sleds. Really appreciate about it. And these are very standard sleds that you can find in a typical traditional data center. And you guys see the configuration of all those sleds right there. Moving on, let's talk about the enclosure, as I said. And this is very unique. And again, thanks to MyTech for providing us the ESA chassis. And one thing we really recognize it because we believe that this is a very ideal use case for the telecom customers where they have a hard requirement to have a legacy 19 inches rack. And you guys see here all the things and the piece parts that this ESA chassis has it. And by the way, thanks to Circle B for providing us the open source switch.
And no, that sound is not part of the demo. I'm not sure what that is. Yeah. Oh, OK. All right, we're validating that we're fine. OK, cool. Thank you for the data. All right. We're doing a live code demo with a live call back to the US on stage during keynote. So, of course, we'll also have some alarms going off. So thank you, Rajeev, for talking about the hardware we've got here. One important thing to note, he mentioned the importance of legacy in telecom. We still have to, we're putting these things in COs, in cabinets, in cell towers. So, we don't get to start fresh with brand new greenfield data centers. So with that, I would like to invite Attilla on stage. Can y'all still hear us, or do we need to?
Well, it should be over in a minute or so.
Yeah, I was going to say, we'll just keep going, because why not? All right, so Attilla de Groot is a senior systems engineer at Cumulus, and Cumulus has been hosting our VCO for us over in San Jose. He's going to talk a little bit about the demo topology for us.
So in our topology, in the spine leaf topology that you saw earlier, what we have connected is the virtual central office. But the important thing is that we have a Faraday cage, and there are 2 phones in there. And what you'll see in the demo later is that we can remote control them both. And I see that we already switched the slide. But let me just go into the demo right now then. So you see the 2 phones here, and the left one actually is not connected. I have switched on airplane mode. And what I'll do is I'll turn that on, and in a bit you should see the 4G connection. As Heather already explained, we didn't have the 5G handsets, but the environment is made for 5G already. So what I'd first like to see or show you that it's actually live. And there's a bit of delay because this is coming from the US. But so I can show some new tweets, and also from the hashtag that we're using for OCP here in Amsterdam. And that should all just work. So we should see the latest tweets here. Now, what are we going to do? So these two phones are next to each other, and the left one is actually going to play some music on its speaker. And we have chosen Heather's favorite song, apparently. So we're going to play that, and on the phone that's next to it, I'm going to call Heather here, and that is going over the VPN connection, over LTE to this branch office. And Heather should be receiving a call in a bit.
Why, look, I got a call right here. And it looks like there is some music playing. So we can't have anybody in the Faraday cage. So the music, the other phone playing music is how we're getting that. So here, we can plug it in. You can all hear, I think.
Or not. Yeah.
All right, so this we can turn.
Yeah.
Yeah. All right, so just to sort of clear up, these are basically emulations of screens back in San Jose, and they just called real time, no smoke, no mirrors, live code, live internet connectivity, live machines here to us on the stage. So I always love it when friends call me and play me Kenny Rogers and Dolly Parton. I now refer to this song as Islands in the Mobile Data Stream. But so if you are interested in learning more about how we've been using open source software and open source hardware to virtualize the central office, look ahead to the edge and look ahead to 5G. We have a booth here at the Linux Foundation networking. We are sort of around the corner that way as you leave the auditorium. And I am doing a session in the engineering workshops in the telecom track tomorrow. So I look forward to seeing you all there if you want more information. All right, and then Rajeev, come on back out because I want to give some great thanks. These are the ecosystem partners who were involved in our project. So we had a number of companies who were bringing together their open source distributions, their proprietary products to help make this work, as well as their hardware. Special thanks to Cumulus for hosting our lab, and special thanks to MyTech and Circle B for getting our branch office together so quickly. And finally, as I mentioned, it was great hearing John's talk about open source this morning. This was a collaboration amongst 5 different open source consortia as well, all of who produce various parts of the stack. OPNFV focuses on integrating this together and sort of bringing it together for telecom use cases. And this was just a really amazing experience. And also, it takes guts to do live code demos on stage. So just thanks again to these guys for all of their work building this up and being brave enough to come on stage and do it. So let's give them a round of applause.
Thank you.